Welcome to the first of 8 brief discussions on the INCTM High Leverage Practices. This is High Leverage Practice number 1, Establishing Mathematics Goals to Focus Learning. In this session, we'll define High Leverage Practice number 1 from the book Principles to Action, which is an INCTM publication. We'll consider the best practices for teachers, and we'll connect Practice 1 to the Danielson framework for teaching. Originally, we were going to do the 7 Idaho Mathematics Instructional Framework practices. This is a slide from what I had created, and then we decided to shift gears, and I wanted to explain that for just a little bit. This is the Idaho Mathematics Instructional Framework, and there are 7 practices. On the bottom, you'll see that it says modified for Idaho students based on principles to action, ensuring mathematics success for all, INCTM 2014. This is that book that it was referencing for the Idaho Mathematics Instructional Framework. The book Principles to Action discusses 8 high leverage instructional practices. We decided to shift to this, and I'll show you kind of a comparison of those two. So here's the 8 high leverage instructional practices on your left, and on the right, it's the Idaho Mathematics Instructional Framework. On the left side, you'll see that there's 8 practices. On the right side, the Idaho Mathematics Instructional Framework, there's 7 practices. I spoke with Angie Godfrey. I've also spoken with Kathy Bills about this before. They had adapted this to meet Idaho's jam. I don't know how to say that any better. Adapted so that it was, gave it a new name. But as they discussed it, they wanted to go back to kind of the 8 high leverage instructional practices. But essentially, they are the same. They're just modified, named a little bit different. And so for this professional development, we'll focus on the 8 high leverage instructional practices. It'll clarify and articulate things just a little bit better. So that's why we've switched. So if teaching practice 1 is to communicate mathematics learning goals, that begs the question, what are the goals, the learning goals? The Idaho content standards for mathematics are broken into 2 types of standards. There are the standards for mathematical content and the standards for mathematical practices. The standards for mathematical content are what teachers normally assimilate with and communicate in their lessons, i.e., students will be able to add 2-digit numbers, or students will be able to use trigonometric functions to solve missing sides of right triangles. The standards for mathematical content are the what of the lesson. The lesser emphasized and communicated standards are the standards for mathematical practices. These stem from the 8 mathematical practices from the National Council of Teachers of Mathematics. We'll talk more about them in depth in a moment, but generally speaking, they answer the why or the how the math content should hopefully be taught. First, let's make sure that we talk about the standards for mathematical content. In grades K-8, the updated 2021 standards prioritize the K standards into major, supporting, and additional standards. And they have a symbol or a shape, either a square, a triangle, or a circle, next to each standard based on the prioritization. When I was on the Standards Review Committee, we discussed the need to prioritize the standards to give guidance to districts, schools, and teachers, and emphasize that not all standards are created equal. Think of the grade level major standards as the trunk of a tree. The supporting standards are the branches, and the additional standards are the leaves. The branches and leaves will come as we ensure that the trunk is solid. It doesn't mean that we'll dismiss or neglect any any of the supporting or additional standards, but we need to prioritize the standards when we look at the vertical alignment of math development over multiple grade levels. The K-9 standards are a little bit different. Recently, Dr. Kathy Beals, the state coordinator for mathematics, brought together high school teachers, administrators, and college professors to review the state math standards. The idea was that students should be able to transition smoothly from high school junior level math classes into college. And so that committee grouped the standards, the 912 standards, into foundational, transitional, or college/advanced standards. I will upload a document where you can actually see that draft. It hasn't been published to the public as of October 1st, 2023, but it's available to you now. You can certainly look at it. The foundational standards are defined as standards that that every high school student should learn, and that generally happens in 9th or 10th grade. Transitional standards are standards that help students transition into their desired field. You can think of these standards as junior year standards or Algebra 2 type standards. There's recently been a movement that not all students need Algebra 2. Gasp! This was hard for me to wrap my head around. But when we think about students being college or career ready, a lot of the fields simply don't need kids to factor a quadratic 3 different ways. These transitional standards are more refined into what would help a student in their desired professional field, whether that's CTE, trades, or a 4-year college degree. So if a student would like to go into business, they might be better served having a transitional year, which we normally think of the Algebra 2 year, with a heavier focus on statistics. Or if they were in the trades, it may be more on measurement and data. So that's the idea between the 912 standards, is breaking them into foundational, transitional, and college advanced. A lot of these college professors would look at some of our high school standards and we're like, we actually teach this in a linear algebra class or college algebra. And so we'd like to help prioritize some of those standards for teachers, schools, districts, for high school at the high school level, so that they can have the same support and prioritization at the K-8 level. The standards for mathematical practices are different, both in the work that should be done by the teacher and the administrator. These standards are often neglected, or at least not explicitly emphasized. If you look at the Idaho Math Standards, you'll see that there is a description for what the standards for mathematical practice should look like at each grade level. This was added in the 2021 version of the standards to emphasize their importance in developing a student's thinking. Likewise, the standards for mathematical practice are assessed on the ISAT. If you look at the screenshot of the SDE website, claims 2, 3, and 4 of the ISAT assess these standards. Angie Godfrey from the Idaho Regional Math Center made this diagram. Pause briefly to look over it. When you're ready to continue, push play. Half of the ISAT is composed of concepts and procedures, questions generally written at a depth of knowledge of 1 or maybe 2, to assess the content standards, the content grade level standards. The other half of the ISAT is problem solving, communicating reasoning, and modeling and data analysis. These questions are generally written at a depth of knowledge of 2 or 3 and are not explicitly assessing content standards. A few years ago, I attended a work session for the company that writes the ISAT. A group of 9 or 10 teachers would sit in a room, and a question would be put on the screen. We would then discuss the question's merit. You may find it interesting that if a claim 2, 3, or 4 question is being assessed, the content that is used can be on or below grade level, meaning that a 6th grader may receive a question that uses 4th or 5th grade content, but is assessing the student's ability to construct a viable argument. One of the talking points I've brought up to teachers in the past is that generally speaking, teachers write assessments based on claim 1 with a low depth of knowledge, only about the concept or procedure. How often do teachers ask a question that has multiple pathways to be solved, or ask your students to critique the reasoning of others? That's much more difficult to do, and it takes a skilled assessment writer. Most textbooks will write their homework and assessments in claim 1 with a low depth of knowledge, assessing the concepts and procedures. We can discuss this further if there's interest, but the question is, if our students are going to see half of their ISAT as a claim 2, 3, or 4, problem solving, communicating, reasoning, modeling, how often are we in our regular classrooms, our teachers asking their students to do that same thing? If you look at the Danielson rubric, component 3A, communicating about purpose and content, you'll recognize where the Idaho instructional framework overlaps. Pause the video and look over the following critical attributes of 3A. What do you notice? Press play when you're ready to continue. When I walk into a math classroom, I'll often see the teacher has posted a content-centered learning objective, usually written using an ICANN phrase, sentence. While I appreciate that they're communicating what content they're teaching, I would greatly appreciate if the teacher would articulate what math practices they're using. Some math we hope students will carry with them for their entire lives, usually basic computation. But the heart of math is in the thinking processes that we're hopefully developing. In the Danielson rubric, you can see in the distinguished category phrases like think critically, connect it to broader purposes. Students use or suggest other strategies, approaches, or processes. That doesn't just happen in social studies, English, science. That can also happen in math class. I cannot tell you how often I've seen a teacher show the students one way or sometimes two ways to solve a problem, and then expect the students to mimic the teacher's actions. Mimicking is not thinking. Mathematics is about logic, reasoning, imagination, and thinking. Do your students allow do your teachers allow your students to run wild with ideas on how to solve a problem? This, if a teacher would be more articulate about not the content, but more about the practice they're using, then we may help them to develop some of these distinguished qualities. This diagram is from the NCSM book, Instructional Leadership in Mathematics Education. This shows the progression of establishing and communicating learning goals. Again, take a moment to pause the video and read over the progression. Press play when you're ready to continue. I would like to reiterate that there should usually be two goals for the lesson. One goal should be content-based, which we normally see. The other should be practice-based, which we normally do not see. As the instructional leader, you can push your math teachers to identify the math practices they're trying to foster in their lesson. As they become more explicit in their use of the math practice standards, their students will be recognizing and learning thinking skills that will transcend mathematics. Remember in the first slide about this, the content standard is the what, but the practice standard is the why and the how. The practice standards are the standards that are going to go with the students. They're the thinking processes that we want to harbor in our students. As a reminder, this is the process for administrators in the Accelerated Learning Program. If you have any questions, thoughts, or comments, please reach out to me. Thank you.